Okay, our next speaker is Andre, and he's going to talk to us about Java, satellites, and Raspberry Pi.
Yeah. Hello, everyone. My name is Andre. I'm a software developer. I'd like to talk about r2cloud. This is software which lets you download the data from satellites. Yet another. I'd like to talk about the design, the features, and a bit of future plans, and answer questions. So, but before I move on, a brief history. So, several years ago, I decided to contribute to space technology and improve our space tech somehow. But for a software developer, it's really hard to do. Really hard to find the niche and all that stuff. So I found a project called SatNox. This project was about building a base station for tracking satellites. I was really excited, and I started building it, trying to run this on my MacBook, compiling. Yeah, I had a lot of issues with it because of different Python versions, different C++. There was a lot of issues I had, and I actually opened SatNox UI, trying to find what the data SatNox can provide and how they contribute to maybe the web server. And I didn't find any data there, only waterfalls and some audio files. So I was really disappointed at that time. And what a software developer would do in such case, I decided to build my own station, of course. And my base station should do all these things. So I should see some pictures from space, right? This is super cool. It's visible. I would like to see any telemetry, the solar panels, voltage, everything should be stable. I should be able to run my base station on solar panels somewhere in the woods and leave it for years. Don't bother with it, and get the data eventually. And my base station should be stable and it should be simple, and it should do one thing: just gather the data from the satellites, but it should do it well. So I started to play with the design a bit, and I came with the following. So it consists of two steps. The first one is very simple. When a satellite comes over the horizon, my base station should schedule an observation from where tells there. It should get the data, zip it, save to the disk for the further processing. So nothing fancy here, super simple. Just save the data to the disk and execute the next step. So when satellite is left the sky, then base station should stop the tells there and just execute the next step. And next step is the following. It reads the data from a disk, simply demodulate it, simply decode it, and save it onto disk result. And optionally maybe save it somewhere centrally for aggregation purposes and sharing with the community and the scientists. And this step could be executed concurrently with the first one, and so that I could optimize the load. Yeah, all I have to do is just simply demodulate and decode the data. Right? So I have no idea how to do it, especially 3 years ago. But I knew that somebody else can do it better than me, right? And I started Googling it and Google it and Google it, and I found a project called Geo Satellites. You may have heard about it, right? So this project contains a lot of satellites and a lot of decoders from a lot of companies, and it's a really good place to look at. Highly recommend the work that Daniel did. And this is a special hard work because the satellite owners, they normally do not share the protocol details, right? And it's really hard to find the way to get the data out of bits. So this project was completely fit my purpose, right? But what the next steps for me to do, right? the first step, I can use GNU Radio, right? Because the Geo Satellites based on GNU Radio, I can use GNU Radio, I can start building it, working with the Python versions on my MacBook, and feeling pain. And essentially, it would be the same what SatNox did. And I didn't want to follow that route. Another option, I could write my own DSP framework, right? And spend my next 5 years trying to debug it and see if it really works. That's too much time consuming. I don't want to do it again. Or maybe I can do something in between. And I did it. I used Java. I decided to rewrite the Geo Satellites piece in Java. Well, of course, I had to rewrite a piece of GNU Radio in Java, right? Why Java, right? The first reason is because I know Java. I'm a Java developer. The second thing is write once, run everywhere. Slogan, it still works. I can run my Java program on my MacBook, run it on Raspberry Pi in production, and test it in Travis CI or somewhere else where Java can run. So this is very convenient. I don't want to install Conan, framework to do the package management and build the different options. And this is single language for the whole stack. If somebody tried to get the satellite data, you might know that you need to compile lots of dependencies for GNU Radio, some dependencies for Geo Satellites, and hope for the best. This is a single language. The thing is, I had to rewrite a piece of GNU Radio. And I did it the smart way. Of course, I decided to implement the interfaces and to make my blocks binary compatible with the GNU Radio blocks. So the input parameters in my Java implementation are the same, and output and input, they are the same. So what I did, I created file source, ran it through the interested GNU Radio block, and save it somewhere. Then I did the same for Java and just compared the result between the GNU Radio output and my own output. And it actually worked. All my blocks are binary compatible up to 5 decimal places. So if it is a float, then 5 decimal places are okay. There's the differences, of course, between the GNU Radio and my own implementation. The first one I'm writing in Java, so in Java we have very interesting peculiarities. So the first thing is a garbage collection and the memory management. So you can allocate buffers and then deallocate them, because that would create a great pressure on a garbage collector. So for that, I pre-allocate everything. So my garbage collector just do not work at all, just don't bother with this. So these blue things are actually pre-allocated stuff. So normally, as you can see, there's no new operator and nothing is allocated. Another major difference is single thread. So I must admit that the scheduler concept is too complex for me. So I decided not to implement it at all. And as Marcus said previously, a single thread might work. And actually, I think it's even better than running on multiple cores. Because if you have a multiple cores, you have to copy the memory from one core to another core, do a lot of synchronization between them, and that could hit performance. And it would be a lot of cache misses as well if I do this on several cores. So I decided to go single thread and write my flow graph as a sequence of blocks. They just change one after another and get an input one from another. So from a programmer perspective of view, they're just blocks, one-to-one. For the JVM, which runs this, is just a lot of cycles. JVM can optimize it very efficiently and compile it to the native code, because everything is executed on the same CPU, on the same on a single CPU. And another thing why I chose this, because I would like to run it on Raspberry Pi. And on Raspberry Pi we have 4 cores. So 1 core would be allocated for this r2cloud. The second core would be allocated to demodulating decoding. The third core might be allocated to some system-wide operations. And the fourth core might be just in case. All right. The third difference is tests. So my inner enterprise developer admires this picture. I wrote a lot of tests, so that's why I'm saying my blocks are binary compatible. I have proofs, of course, and I wrote a bit more tests for the decoders as well. So I took some data from a satellite recordings project, which is run by Daniel as well, and some data from r2cloud, my own project. So what's the difference between the two? So satellite recordings, they contain very strong signal, which is very useful when you want to do to test for your decoders. You want to make sure that you understand protocol properly, and yeah, it's easier to do reverse engineering. But if you want to decode signal in the wild, you have to deal with a multipath, with the Doppler, with a neighborhood antenna, and whatever might comes up. So I have 2 types of tests for these. One for the protocol, and the second one for the real-time signal, which I collected from antenna. And 3 years later, well, nearly, I've implemented some satellites, the active satellites from Geo Satellites. I've implemented all transient repositories, because the satellite owners, they provide some code which is useful, but it's not normally doesn't normally fit into other stacks. So I've implemented everything and just run it on a single thing. Libfac, everything. And I got result. This is a real telemetry from real satellite, from real space. It contains some boot count, some voltages, solar panel thing, whatever. Really cool thing in JSON. Yeah. Also, my base station can automatically schedule the next passes for some satellites. As you can see, the green line is a line where I was able to decode at least 1 packet. Yeah, so as you can see, some I was not able to decode, some working fine. Then I can aggregate the data. So several base stations can transmit the data, and I can analyze it on a central place, somewhere here. And you can share this data with the SetNox again, with some researchers, FunCube, Warehouse, whatever. And a great bonus, I have a real picture from space. Here it is. This is a night this is night side of Earth, as you may see. And this one is a bright one. This is an image from Meteor M. This is a Russian satellite, protocol LRPT. Yeah, and it can transmit the data, and one day I can put this image onto the Google Maps and see how the weather changes over time. But for now, it's there. Actually, it looks much better on my laptop. Yeah, I'm used to Discord antenna. Oosh. This is very simple, basic, and with a negative gain. But it fits my purpose. Then a very standard block V3, that's what's there. Raspberry Pi. Right. I'm talking about Java, but never said about performance, right? But as I say, the performance is not really needed here, and here's why. The first thing, a satellite, they transmit the beacons one way only. So you cannot reply it to the signal. So this is one-way transmission. No need for real-time. Then RTL-SDR. This is only the receiving. It can only receive the data. So even if I can respond to it, the RTL-SDR doesn't allow me to do it. So I don't really real-time response to these packets. And no one on Earth is really interested in getting real-time beacons in his university. Okay, give me more data. I can spend any amount of time doing decoding. I've run some performance metrics. So for CubeSat, this is a very narrow band signal, 10-15 minutes for the full pass. So this is nearly real time because it takes nearly 10 minutes for the satellite to pass over. And 1.5 hours for Meteor-M. Oops. But that's not really Java related. This is what I'll be doing. Anyway, performance is not really needed in this for this kind of software. I can optimize it maybe just to reduce power consumption and run on solar panels. But for now, it's okay. All right. What can be improved? Demodulators. They definitely need to be improved. I haven't found any resources which clearly state what the parameters for demodulators are standard. So I have only BPS. I have only bear curve for BPSK demodulator, and that's it. Maybe I need more parameters like time to log, time to relog the signal, any other parameters. For FSK demodulator, we need bear curve or whatever. Multipath propagation is not covered here as well. So this is just AVGN channel. Yeah, and I need more demodulators, FSK, QPSK, all SK parameters, real-world signals. The lack of them, but it's getting better. More satellites, as Daniel pointed out. Satellites constantly launching in space, and they're constantly falling on Earth. So this never-ending battle between the Earth gravity and satellites. And we started to support them more and more. Maybe FPGA stuff to optimize the modulators and reduce power consumption. Yeah, and this is it, I think. Thank you for your time. Thank you for listening. I have open to ask questions. The question was, what support for famous RTL? Well, I support for any RTL-SDR compatible sticks. So if they can be run with RTL-SDR program, then I can support them.
Is there a plan in the future for an SPI device?
No, I'm a single developer. I can support the variety of hardware, so just only one.
If you could go back to the bit error rate slide that you mentioned, you needed a better demodulator.
Sorry?
You mentioned that you needed a better demodulator?
Yes.
Yeah. So you're actually better than theoretical max.
This is a so my demodulator is a red one. So it's
For ethno equals 1.
I think.
That's the classical, sorry that I interrupt, that's the classical ER approximation for BPSK. That's wrong for low SNRs. And there's about 1 million papers out there that use the MATLAB ER curve. And they're all wrong because for low SNRs the curve is wrong.
Yeah. But this bear curve covers on the AVGN channel. If I want to test against the multipath propagation channel, then the bear curve will be different, and it might be worse than the theoretical.
But even for the high SNRs, you're only like...
Yeah, it looks good. Yeah. So I spent some time on tuning it. And actually, I took a lot of code from Geo Satellites to do it. Yeah.
Right, thanks.
Question?
Why use Java instead of integrating inside the
So can you?
Why use Java instead of generating inside
Yeah, because of complexity. So if I want to run my thing on a MacBook, then I need only Java dependency. If I need to run GNU Radio, I need a lot of dependencies and dependencies of dependencies. And sometimes it's not very convenient. And sometimes I want to run the tests in cloud. So all the tests they're running in cloud, in Travis CI integration. So I'm not sure if it would ever possible to install all these dependencies there. Questions?
Yeah, have you tried generating these signals as well and decoding these with your tools?
Sorry?
Have you tried generation of the...
No, I just focused only decoding. Sorry?
Did you also plan to put this onto the space segment of the satellite, or is just receiving segment you include? I mean, could this be on a?
Yeah, the question was, is there any plans to put on a space segment? I think it's not my choice. So if anyone would like to use it, it's freely open. Just use it, see the data. You can just open GitHub and see the tests. Everything's there.
Do you see the possibility of?
Yeah. So all decoders, yeah, it could be possibly used. Yeah. All right. I think this is it. Thank you very much.